6.2, the law of sines. Mhm. Okay, let me try to give you the formula. So given some, it's not an equilateral triangle, just know that it's not a right triangle. Okay. So A is over here, so that means little a has to be over there. B is up here, so that little b is down here. Capital C is here, so little c has to be over there. So there's no hypotenuse. It's just some triangle. Okay. Okay. So these are the formulas we're going to use. So A over sine A is equal to B over sine B. They are all equal to each other. Also, the reciprocals are equal to each other. So you can use the one that feels easier, depending on the situation, just to save a couple of algebra steps. So like if what you need is up top or on the bottom, then solve for it, right? So this is my first set, second set. Okay. Now you can solve for the angles and make another set of formulas. I'm gonna go ahead and do that for you just because maybe it'll make it easier, maybe not. But what I could do is say that A is equal to sine inverse of little a sine B over B, or sine inverse of mm, little a sine C over little c. So you can use these to find angle A if you need to. Basically, I'm just solving for A in two possible cases. So I'm making you a formula. So you're welcome to use it if you want. You don't have to. It is unnecessary, but it might feel easier. You want to just plug in numbers and not worry about it. Capital B would equal B sine C over C. Capital B is also equal to B sine A over A. C would be equal to sine inverse and this one. So I don't think these are in the book. I'm just making them myself, but they might be. I don't know. Um, There we go. All right. So we're going to use these. They're also some of these main ones are on your formula sheet. These are just I just solve for A, B, and C on all the possible cases. So you can just plug in numbers and you'll get what you need, right? So if you have C, A, and little a, then use this one. If you have B and little b, then solve for this. Use this guy to get C, and so forth. So you can choose what's best in what scenario. Okay. Or you can, individually solve it by equating these pieces. So let's do the actual question. This is number one. Consider the ABC triangle and solve it. Trying to shorten this up. They did not give me A. They gave me capital B, gave me capital C, lowercase a, lowercase b was not given. I think that's it. That's all they gave us. So it's some triangle. I'll draw it for you. Okay. Sorry for my ugly drawing, but they didn't give you the picture in the question, but it helps to kind of draw it out. Okay, so what's capital A? That's an easy one to find. We don't even need the law of sines, right? It doesn't matter where you put the A, B, C. What matters is that the lowercase is on the opposite side. See how I have capital A and lowercase a, capital C, lowercase c, capital B, lowercase b. As long as you set it up that way, where they go doesn't matter. And you cannot use the law of sines unless you have an angle and its opposite side. So right now, none of the angles have their opposite sides, and this angle is missing, so I can't do law of sines. So I have to find capital A first. Without capital A, you can't do anything. So that's the easiest part, right? Looks like 26. I'm gonna box the ones that we find so I don't forget what we solved. Okay, now that I have that, I can use the formulas or I can set them up to solve for B and C. So what I'm gonna do is purposely use this one and set it equal to the A because it has both. So solve for B. I'm going to multiply both sides by sine B. That gets me to here. Then I'll just plug in your numbers and I'll have side B. Are you cool with me skipping the algebra here? Do you see how we got from here to here? All right, so let's just plug it in. We get 60 sine of 31 over sine of 26. This, I'm put parentheses for the numerator. 60 sine 31, parentheses, divided by the denominator, sine 26. So side B is 70.5. Okay, so I have another piece. So far, is this okay? Is it making sense?
Yes.
Okay, let me know if it gets weird. I think the next one's going to be hard, but before we get there, I'm hoping this one makes sense. All right, so we set this up in order to find B. So now I'm gonna do the same thing for the C. Okay, so here we go again. C over sine C is equal to A over sine A. Isolate your C. So C is equal to A sine C over sine A. Plug in your numbers. 60 sine 123 over sine 26. Now we have, let's see here. You can also use the fraction button to make it prettier. You know, you can use the parentheses like I did before. Doesn't matter. 114.8. Okay, so we've used law of sines to find all the sides. And the angle is pretty straightforward. Let's look at their solution, see what they did. I think seeing it again or in a different way might be helpful. The first thing you did was solve for the capital A because we had two angles. Then they set this guy equal to the B part, set solve for B, plug in the numbers and got 70.5. That's what we got. Then set the A over sine A again equal to the other part. Isolate the C, plug in your numbers. They went ahead and plugged it in right away. I plugged it in at the end. It doesn't matter. Just I thought it looked neater, but who cares? Anyway, pieces that they wanted was capital A, lowercase b, and C. There any questions on the work or idea? So whenever it gives you two angles, the question will be kind of easy, similar to this, but if they only give you one angle, then you get the possibility of one triangle, two triangles, or no triangle. Then you got to figure it out. So that's when the law of sine kind of sucks. Uh, but this one, it gave us two angles. So whenever you see two angles and you have a way to find an opposite side, then you're good. It's going to be easy or easier than the other type. If you get only one angle and you can still use law of sines, then it's going to be a little challenging. But yeah, cool on number one, because I think the next one is the weird one. All right. I'm going to assume yes. Notice on this one, like I said earlier, they only give us one angle, but you do have an opposite side. So I can start finding the missing angles, but whenever you solve for an angle, there's a possibility of two solutions. Sometimes they both work, sometimes neither one works. So that could happen. Um, Let me show you. So this is the case where you have side-side angle, meaning you have just one angle and your corresponding side. So check it out. Back on the unit circle, remember when you would solve for an angle, you had two possibilities. You have the one in the quadrant one or the one in quadrant two, because they're both for sine. You both had a yeah, they had the same y value in two locations. So technically, you have two solutions. Um, so you have to set it up this way. Do you see why there's two answers? Or should I pull up a unit circle and remind you? Okay, let me find it. Where the hell is it? Here we go. Okay, can you see the unit circle?
Yes.
Okay, so let's pretend we were solving, let's say, how do I put this? So suppose I wanted to solve for this x. What you should do is apply the sine inverse on both sides, or arc sine, or the definition. So when you punch this into your calculator, let me show you. Or maybe punch it in yourself. Sine inverse of zero point 0.5 is going to give me 30 degrees, which we can see the answer here, right? The calculator should give me 30 because sine 30 is equal to 1/2, right? So it makes sense that this has to be 30. Is that part clear?
Yes.
So where it gets kind of weird is there is two solutions because technically it's also true over here. But the calculator will not give you the 150. It will only give you solutions um, at this side of the circle. Okay. So how do I get this other one? Well, if my first solution to this equation, right? If I'm solving for this guy, the first x is 30 degrees. The second one will be 180 minus that solution. That's how you find both. Without, like if we didn't have a circle, or if your angle is weird, this is what you would do. So because I did an easy one, 1/2 that is on the circle, we could see them here and here. But if it wasn't easy, let's say it was like, I don't know, 0.78 or something weird, then your calculator would give you some weird number here. So as long as you do this again, you'll get your answer. Okay, so that's what they're doing over here. So check it out. Let's go back to the question. Where is it? Oh, here it is. Okay. So they find the first one, like we did, right? This is like our 30 degrees right here. This is like our 150. So they're saying, well, to solve for B, I need to do sine inverse of both sides, which gets me to here, which gets me this answer. To find the other angle, I do 180 minus this answer, which is this. Same thing. That's why they get two solutions. This is like the 30 and the 150 example. You see what I mean? So they're just doing what we just did, except their numbers are ugly and ours were pretty. That's it. It's the same thing. So when we go through all this work and we get to the part where we solve for capital B, we have to deal with the fact that there's two locations. So it might have two triangles or it might have one. Now, this is how you test for it. If you're like, well, how do I know if there's two triangles? Well, once you solve B1 and B2, add them to the angle that you were given and see if it's too big. So let's say you take the one you just found and add the one that you started with. And if it's less than 180, then yeah, that answer is cool. If you add this one and this one, and it's all still less than 180, then that means you have two solutions that are allowed. So now I'm gonna have two different triangles within one triangle, which is why these type can be hard. So the actual algebra is going to be exactly the same that we just did in question one. Everything will be the same. The new thing is doing this part and then testing these two answers. So then we're going to have two sets of triangles to solve for. Okay. So right here, once you find so find all your solutions using B1. So once you have B1, we're going to do what we did before, right? Just plug the B, so isolate the C or capital C, and then you're going to find the angles that correspond to B. Okay. So you'll have your first set of angles, triangles and sides, sorry, angles and sides, and then you do it again using B2. And then you'll have two sets. So you're going to have, I don't like how they wrote it. They should denote this differently. Like, hmm, I'm going to call this A prime and B prime, or B1 and A1, like they did. But notice that the C doesn't matter. The C stays the same, and so does the other C. Have a nice picture. So let's go through it together and show you how the steps are supposed to go. But that's the big picture and why there's two B's. Okay. So I'm telling you it's a two triangle case that they don't actually tell you. I'm just labeling it that. So we got A, call it A1, B1. We don't have those. C will be the same for both triangles. A1, B1. C will be the same. We have an A2, a B2, and the C, the same still. I'll send you some extra videos too, because it's hard to grasp the first time around, so don't feel bad if this seems difficult. Okay. I think you gotta look at it a few times and do a couple. So I'll send you some more extra examples later. But anyway, what else were we given? Oh yeah, B1. Double check everything before we get started. Okay, so let's solve for capital B. I don't think that we'll have another B1 for lowercase, but we'll check in a second. I'm obsessing. Let's move on. So use this guy, opposite side and angle, to find this capital B. Remember I wrote a bunch of formulas. We said B was equal to sine inverse. I don't remember. B sine C. Yeah. Larry, let me see if I can fix that. That's better. All right, so plug it in. Sine inverse. That will give us B1, which on the calculator, I believe that is 42. Did I say around the nearest tenth? I think it did. Yeah. There we go. Now B2 is equal to 180 minus this whole thing. So punch that into your calculator and you'll get an approximation of 137.1. So like because we had only one angle when we started, we have the possibility of two triangles. Now I know it's going to happen, so I wrote this out. But let's pretend we don't know, and we want to test to see if there is. So test B1 and B2. So take check if C plus B1 is less than 180. and C plus B2 is less than 180. That'll be 31 degrees plus 42.9 degrees. That is less than 180, right? And 31 degrees plus 137. So yes, right? Since both are below 180 when you add them together, then we have two triangles to solve. So do you see how you check? You check the one that you were given, add it to the one you solve for, and its pair. And if they're both below 180, which they are, right? Then they both work. So you have two triangles. Are there any questions on that part? Okay. So you got a B1 and a B2. So now capital A1 and A2 should be pretty easy, right? How would you find these guys? So all you got to do is solve for A1, A2 using B1, B2, and C. So A1 is equal to 180 minus B1 minus C. A2 is equal to 180 minus B2 minus C. So that's going to be what? Let me write it out first. So just punch it into your calculator and you'll have A1 and A2. So we're almost done with the two triangles. So this would be 106 And this will be 11.9. Pretty sure. Did I do that right? Yeah. Is there any questions on A1 and A2? Yep. Is that okay? So now find the missing side, A and A1, or A1 and A2, lowercase, and we should be good. All right, go to the next page because there's not enough space here to do that. Now solve for A1 and A2. Okay, sorry, lost my train of thought. Alrighty. So I'm looking for little a. Set this equal to C sine C. So A1 is equal to C sine A1 over sine C. Punch that into your machine. I don't remember what C is. Should be 28 if sine 11.8905. Put in more decimal points just in case. Divided by sine 31. Okay, 11.2. There's A1. Then I'll do the same thing again, but with A2 and sine A2. So A2 is equal to C sine A2 over sine C. Actually, I think I messed that up. Hold on a sec. Yeah, I didn't plug in the numbers. Let me do that again. Sorry. There we go. Yeah, let me double check. C is 28. Sine A 106.1 over sine 31. And that will be on the calculator 52.2. Plug in the numbers this time. Don't make a mistake here. This will be 28 sine of A2, 11.9 over sine 31 again. Oh, there we go. Hmm. So because we had that weird case, we had to find two triangles. Let me try to give you find a visual. But is there any questions on this problem? Let me try to find a nice picture. Hmm. Okay. So this is why it happens. Do you see the triangles?
Yes.
So basically, in our case, we had a fixed C. They have a fixed A. But basically, when they solve for B1 or let's say C, let's say like C1, they solved for C1 and they ended up having two solutions that worked. They added a C1 to A, and it turns out they're both below 180. So therefore, there's two possibilities. So either the C will come out this way, or it'll come inward because the angle will be different. Remember how when we solved for it, we said do the sine inverse and you'll get C1, then do 180 minus C1 to get the other one. So basically, it's folding in or out, creating two separate triangles. So the stuff that they give you, the angle and its opposite side is not going to change, but everything else is going to shift a bit. But this one is still the same length. It's just coming in or coming out. So all you have to do is solve for these two separately once you find your first angle. Does that make more sense having a visual, like what's happening?
Yes.
And I'll send you a couple examples, just in case, because the first time I did this, I was just like, what the hell's going on? But it's not too bad. It's just kind of annoying once you get it. It's not too bad. Okay. Alrighty. I guess we'll stop here. I'm gonna send you some examples in this videos in just a moment, if not in the morning, as soon as they finish loading. And if you have any questions, let me hit pause here.